Welcome to the first lecture on Introduction to Chemistry. Today we will be exploring atomic structure, the foundation of all matter. Atoms are the basic units that make up every substance, from the air we breathe to the materials we use daily. The concept of atom dates back to ancient Greece, where philosopher Democritus proposed that all matter is composed of invisible units. Later, in the 19th century, the English scientist John Dalton developed atomic theory to explain how matter behaves. Atoms are incredibly small, so small that even with an electron microscope we can only see faint outlines in direct images of atoms. Despite their size, atoms are made up of even smaller particles: protons, neutrons, and electrons. These subatomic particles play essential roles in the structure and behavior of atoms. To open today's lecture, I have selected the world-famous painting Starry Night by Vincent van Gogh. The swirling, vibrant forms in the painting evoke for me the unpredictable and energetic movement of electrons. In many ways, the dynamic patterns mirror the behavior of electrons and the complexity of orbitals, an essential concept in atomic structure. That's my perspective. By the end of today's lecture, I had loved to hear how you interpret it. I often hear from students that they struggle with chemistry. The main reason for this is that they tend to forget the basic concepts that they learn at the beginning, which are essential to remember throughout the entire course. So let's start with the fundamentals. I am going to remind you of something that you likely learned around the age of 11 or 12, and that is negative numbers. Remember, -1 plus -1 equals -2. In chemistry, the concept is straightforward. What matters is the overall charge of the atom, whether it is positive or negative. We don't always need to focus on the exact number of positive or negative charges, but rather on the balance between them. If an atom has more protons than electrons, it will be positively charged, and if it has more electrons than protons, it will be negatively charged. Well, the charged atoms we even do not call atoms, we call them ions. We will talk about this concept later on during the lecture. This concept of charge is fundamental in understanding how atoms interact with each other in chemical reactions. Let's start with the basics of charge. If we have 3 positive particles, protons, and 1 negative particle, electron, the overall charge would be positive, since the positive charge outweighs the negative. Now let's consider a balanced example. If you have 8 positive charges, protons, and 8 negative charges, electrons, what's the total charge? 0. The charges cancel each other out, leaving the atom neutral. So when an atom has an equal number of protons and electrons, it becomes electrically neutral. Another thing to keep in mind is that unlike charges attract, while like charges repel. For example, if we have a positive particle and a negative particle, they will be drawn together. However, if we have 2 positive particles or 2 negative particles, they will repel and move away from each other. This principle is important because the opposite charges of protons and electrons are what hold an atom together. I may have spoken ahead earlier, but as I mentioned, protons carry a positive charge and electrons carry a negative charge. With this in mind, let's take a look at the structure of an atom. Let's randomly choose oxygen. Why not? Like all other atoms, an oxygen atom has a nucleus. We will shade it blue. This nucleus is made up of 2 types of subatomic particles: neutrons and protons. Neutrons are neutral, as their name suggests, and protons are positively charged. This small dense cluster of neutrons and protons is called the atomic nucleus. Surrounding the nucleus are electron shells, and in case of oxygen there are 2 electron shells. Each electron shell contains electrons. which are negatively charged. What you see here is the electron cloud around the nucleus formed by these electron shells. Protons and neutrons are roughly equal in mass, and both are much heavier than electrons. This is why protons and electrons make up most of the mass of an atom, and by extension, most of the mass of the universe. Remember the principle, unlike charges attract and like charges repel. This is what keeps protons and electrons bound together, holding the atom intact. In an oxygen atom, there are 8 protons. Therefore, how many electrons should there be? 8 electrons, since the number of protons and electrons in neutral atom is equal. What you're looking at here is electron cloud around the nucleus made up of 8 electrons. A positive 8 from the protons plus negative 8 from the electrons equals 0, which means the overall charge of the atom is neutral. The number of protons in an atom is called the atomic number, and each element has its own atomic number. So what is the atomic number of oxygen? It's 8. And what is the atomic number of hydrogen? 1. Hydrogen is the simplest atom consisting of just 1 proton and 1 electron with no neutrons. Now, what happens if a hydrogen atom loses its electron? Well, when 1 proton remains, we refer to it simply as a proton. We usually abbreviate it as H+, hydrogen ion or proton. But it is no longer an atom. It becomes an ion. Let's review everything and answer questions step by step. What type of charge does an electron have? Electrons carry negative charge. This is a fundamental concept that students often forget, which leads to struggles in chemistry. Although it seems simple, it's crucial to remember. What type of charge does a proton have? Protons carry a positive charge. What about a neutron? Neutrons have no charge. They are neutral. What is the charge of an electron cloud? The electron cloud, made up of electrons, carries a negative charge. What is the charge of the nucleus? The nucleus is made up of neutrons, neutral, and protons, positive. Since the neutrons are neutral and the protons are positive, the nucleus overall has a positive charge. What is the overall charge of an atom? An atom is electrically neutral because the number of protons, positive charges, equals the number of electrons, negative charges. For example, in an oxygen atom, there are 8 protons and 8 electrons, balancing the charge. Now let's move to another key point. What is an atomic number of sodium? The atomic number represents the number of protons in an atom. Sodium has an atomic number of 11, meaning it has 11 protons. The nucleus carries a positive charge, while electron cloud carries a negative charge. These different charges keeps the atom together. The atomic number is determined by the number of protons. Dmitry Mendeleev, a Russian scientist, created the periodic table by organizing elements according to their atomic numbers. At the time, some elements were unknown, and there were gaps in the table. However, Mendeleev predicted that these gaps would be filled as new elements were discovered, which later proved true. Yes, this has been proven true with the discovery of new elements. As I said, Mendeleev created the periodic table by organizing elements according to their atomic numbers. For example, hydrogen has 1 proton, so its atomic number is 1. Sodium has 11 protons, so its atomic number is 11. Helium has 2 protons, so its atomic number is 2. Now let's summarize atomic structure. Atoms consist of subatomic particles, protons, neutrons, and electrons. Protons and neutrons reside in the nucleus, the core of the atom, while electrons are found in the electron cloud, the outer part of the nucleus. Protons are positively charged. Electrons are negatively charged, and neutrons have no charge, making them neutral. When we look at the atomic models, each electron is represented by a small dot on its orbital. Even though we don't always label these dots with an E for electron, you will recognize them. For instance, in an oxygen atom, the electron cloud consists of 8 electrons. 2 in the first shell and 6 in the second outer shell. And here is extremely important information. Although I will cover it in more details in my next lecture, please pay close attention to unpaired, non-paired electrons. When asked to identify unpaired electrons, always focus on the outer shell of an atom, not the inner shell. For example, oxygen has 2 unpaired electrons on its outer shell. Do you see it on the slide? Hydrogen, the simplest atom, has 1 electron and no pair. Now, how do we determine the number of protons? By counting the electrons in the electron cloud. In an oxygen atom, there are 8 electrons, so there must be 8 protons in the nucleus. Remember, in a neutral atom, the number of protons and electrons is always equal. What about neutrons? The number of neutrons may differ between atoms of the same element, which is how isotopes are formed. For example, carbon-12 has 6 protons and 6 neutrons, while carbon-14 has 6 protons and 8 neutrons, and carbon-13 has 6 protons and 7 neutrons, giving them different atomic masses. The mass of an atom is concentrated in the nucleus, as protons and neutrons are much heavier than electrons. In hydrogen, which has no neutrons, the mass is essentially that of the proton. Now let's look at sodium. Sodium has 11 electrons, so it also has 11 protons in the nucleus, along with 12 neutrons. Chlorine has 17 electrons, so it also has 17 protons in the nucleus. So far we were looking at the Bohr-Rutherford model of atoms. In atomic physics, the Bohr-Rutherford model, developed by Niels Bohr and Ernest Rutherford in 1913, describes an atom as a small dense nucleus surrounded by orbiting electrons, similar to planets around the Sun. However, this is a simplified representation. Electrons do not move in fixed orbits like planets. They jump between energy levels more like fleas on an animal, though they spend most of their time in specific areas called shells. Everything in repetition. So let's review some basic atomic structures. How many electron shells does an oxygen atom have? It has 2 shells, correct. How many electron shells does the hydrogen atom have? 1 shell, correct. How many electrons does a nitrogen atom have? Nitrogen has 7 electrons. How many unpaired electrons does a nitrogen atom have? Take a close look. Nitrogen has 3 unpaired electrons in its outer shell. Remember, when we talk about unpaired electrons, we are always referring to an outer shell. In nitrogen, there are 3 unpaired electrons. 1 here, 1 here, and 1 here. How many unpaired electrons does a sodium atom have? In a sodium atom, there is just 1 unpaired electron. Here it is. How many electrons does a carbon atom have? Carbon has 6 electrons. How many protons does a carbon atom have? Correct, 6 protons. How many protons does a nitrogen atom have? 7, correct. What is an atomic number of carbon? 6. Now for the big question. What is the overall charge of an atom? The overall charge of an atom is neutral because the negative charge of the electrons balances the positive charge of the protons. Since an electron has a charge of -1 and a proton has a charge of +1, atoms are electrically neutral, meaning they contain an equal number of protons and electrons. So if an atomic nucleus contains 92 protons, as in uranium, there must be 92 electrons to maintain neutrality. Remember, an element is a type of atom. Let's discuss the symbols we use for elements. Some elements are represented by first letter of their names, such as capital O for oxygen, capital C for carbon, capital H for hydrogen, capital I for iodine, which means violet due to the color of iodine vapors, capital N for nitrogen, capital P for phosphorus, from the Greek word meaning morning star, because phosphorus glows in oxygen. Capital S for sulfur, it comes from the Latin word meaning to burn. Capital F for fluorine, from the Latin word meaning to flow. Some element symbols use the first two letters of their names, like capital C, lowercase a, for calcium, from the Latin word for lime. Capital B, lowercase r, for bromine, from the Greek word for stench. Capital A, lowercase l, for aluminum, for the Latin for bitter salt. Capital S, lowercase I, for silicon, from the Latin silex, meaning flint. Capital B, lowercase a, for barium, from the Greek word meaning heavy. Nickel comes from the German Kupfernickel, meaning devil's copper. Miners originally thought they had found copper, but were tricked by the new metal, hence the name. There are some elements whose symbols are the first and the third letters of their name. These are chlorine, magnesium, and zinc. Some elements derive their symbols from Latin names, such as sodium. Latin name is natrium. Symbol is capital N, lowercase a. Potassium. Latin name is kalium. Symbol is capital K. Iron. Latin name is ferrum. Symbol is capital F, lowercase e. Lead. Latin name is plumbum. Symbol is capital P and lowercase b. Gold. Latin name is aurum. Symbol is capital A, lowercase u. Each element has an atomic number, which is the number of protons in its atomic nucleus. In an uncharged atom, the atomic number is also equals the number of electrons. The atomic number is written as a subscript to the left of the element symbol. The atomic mass is a combined number of protons and neutrons in the atomic nucleus, and it's written as a superscript to the left of the element symbol. For example, in helium, the upper number represents the atomic mass. Knowing both the atomic number and atomic mass allows us to calculate the number of neutrons in an element. For example, oxygen. Subtract 8 atomic number from 16 atomic mass, and you get 8 neutrons. Phosphorus. Subtract 15 from 31 to get 16 neutrons. Nitrogen. Subtract 7 from 14 to get 7 neutrons. Here it is. By using the periodic table, you can easily find the atomic mass, atomic number, and number of neutrons for any element. These simple subtractions lead us to better understanding of atomic structure. With that, I conclude this short lecture on atomic structure. I look forward to seeing you in our next lecture on inorganic and organic compounds. See you then! you.